unit number 6 is what we called it. Using exponent rules, distributive properties, and combining like terms to simplify expressions. It's kind of a big umbrella, and the problems come in a variety of different formats. So let's take a look at some representatives of each at the beginning level and the intermediate and advanced levels. So I'm going to kind of break this out a little differently than we have for the other units. And at both of these levels, I want us to think about how the picture is a little bit different for working with monomials versus working with polynomials. So for each of our levels, I'm going to have one kind of problem for each. When we're dealing with monomials, all that we have to keep in mind are our exponent rules. There's not any really sort of, well, I guess there's technically a distributive property that applies to that, but there's not a lot of kind of what we come to think about as the polynomial kinds of skills that we work with are a little bit more. So we'll talk a little bit about both. At the beginning level, what we want to do is be able to use let's call them single applications of exponent rules. So in other words, a beginner level skill in the realm of monomials might be to take, I'm going to ask you here to simplify, take two powers of a common base, let's say x, and multiply them together, x to the 7th times x to the 3rd. How would I simplify that product? Right, so the solution here is to add these two exponents. Now, how do we know when to add exponents? Right, when two powers of the same base are being multiplied, when I bring that arithmetic from the powers up into the exponents, it changes from multiplication to addition. So, as you said, what we get here is x to the power 10. That's usually the first exponent rule that we learn. What changes if instead of multiplication, I choose division instead? So I'm doing the opposite of multiplication. What do you think happens to the exponents?
You subtract.
Right, you do the opposite of addition. So here I'll get x to the 4th. Now it bears mention that usually we don't write a division sign like this very often, if at all. We might write it when we're doing some arithmetic, but it's bad practice because in some cases it can create ambiguities in Facebook memes for reasons why people might read it differently. So usually division will be written with the fraction bar instead, because there's an inherent grouping that a fraction bar brings to the table that reduces the chance of misunderstanding. So division of powers of a common base leads to subtraction in their exponents. What if I raise a power to a power? X to the 7th raised to the 3rd. Then what arithmetic happens to these exponents?
You just write it out as x to the 7th times.
Yeah, so we could write it out as x to the 7th times x to the 7th times x to the 7th. And now that I have all these times going on, what do I do with these exponents? Add them together. 7 plus 7 plus 7, that's going to give me 21. What's the shortcut to get to that 21? Shortcut, and there's a good reason to take the shortcut, because what if I were doing x to the 7th to the 20th? I wouldn't want to have to write out x to the 7th, x to the 7th, x to the 7th, x to the 7th 20 times. I would just abstract the arithmetic that we did down there into realizing that what we really accomplished was multiplying 7 by 3. So when a power of a power is taken, the exponents multiply. And there we go. So being able to just identify in one situation which exponent rule is appropriate to simplify some monomial arithmetic, that is our beginning level skill for working with monomials. Let's talk about the polynomial beginning level skill. At the polynomial beginning level skill, all that we're going to end up doing is add or subtract two polynomials. And the key skill here, the key skill here is combining like terms. So here's an example problem. Let's say I want to take y squared minus 3y plus 1, and I want to subtract from that the polynomial y squared plus 4y minus 7. So I just want to subtract these two polynomials. How should I do it? One way to look at this is we're just going to subtract the like terms from the polynomial on the right from the polynomial on the left. So that's sometimes called the vertical method of subtraction. So I have my y squared from the one on the left and the y squared from the one on the right. When I subtract them, how many y squareds do I end up with? None, right? So that's going to just cancel itself out. I have a minus 3y from the one on the left and a 4y from the one on the right. When I subtract them, negative 3 minus 4 is going to give me how many y's? Negative 7. They have this negative 3 minus 4 is addition of two numbers, both of which are negative, and so the absolute values add. So negative 7y. And then the constants, I have 1 from the polynomial on the left, negative 7 from the one on the right, and I'm subtracting. So 1 minus negative 7 gives me positive 8. So really this is just a combination of like terms. Okay? The subtraction of the like terms from the polynomial on the right with from the like terms in the polynomial on the left. The other way, this was what we call the vertical method, because it's arranged just like we arrange a subtraction problem in 3rd grade or whatever, right? We just subtract down the columns. The other way to do it is called the horizontal method, and in that method we end up distributing this minus sign across the parentheses and then turning this into y squared minus 3y plus 1 minus y squared minus 4y plus 7. And then, again, just combining the like terms that we see there, and we get negative 7y minus 8. So whichever way you look at it, you are welcome to take either the horizontal or the vertical method as your means of solving these problems. So let's talk about the intermediate level. So at the intermediate level, working with monomials, once we're comfortable using a single exponent rule within a problem, we start seeing problems that require us to use multiple exponent rules. Okay. So more than one in a single problem. An example of that might be to simplify the expression 2x to the 5th y squared quantity to the power 3, and then multiply that by minus x squared y to the power minus 2. So what should we do in this problem to get our ball rolling? According to the order of operations, what do we want to do first? Exponents. First thing we should do is any exponentiation. So this third power that applies to this quantity, we should worry about that before we worry about multiplying. So the first thing I'll do is apply that third power to each of the 3 factors inside the parentheses. So this is a kind of distributive property. It's a distributive property of exponents over multiplication. So what I'll end up with is 2 to the power 3 times x to the 5th to the power 3 times y squared to the power 3. And similarly for the exponent in the factor on the right, distribute the negative 2 into each of the 3 factors inside these parentheses. This first factor here is really a negative 1, which is a place where it's really easy to screw stuff up. Okay? Really easy to sort of lose where those negative signs are going. Then I have x squared to the power negative 2, and then I have y to the power negative 2. Okay, so we did all of the distributive property business. Now, for each of these expressions, each of these factors, we go back to using a single exponent rule to simplify them. How do I simplify, for example, x to the 5th to the power 3? What do I do with those exponents? Which of these 3 examples does it most resemble? First, second, or third? Look at this part right here. The third one, the power of a power. And what do we do to those exponents? We multiplied them. So 5 times 3 gives me for that factor an x to the 15th. Likewise, y to the power 2 cubed is going to give me y to the 6th. X to the power 2 to the minus 2 is going to give me x to the minus 4. And y to the power minus 2 is, well, it is what it is. What's 2 to the power 3? 2 times 2 times 2, give me an 8. What's negative 1 to the power negative 2? Now's a chance for us to talk about negative exponents one more time. What does it mean to raise a number to a negative power?
Put it at 0.
Not quite. So raising something to the power 0 turns a quantity into 1. Raising something to a negative power exchanges multiplication for division. So what it really means is raise it to the power positive 2, but have it in a denominator instead of in a numerator. Right? So negative exponents mean that factor just needs to be in the other part of the fraction. Exchange multiplication for division. If I turn it into a denominator instead, then I can make the exponent positive. And we know what it means to raise negative 1 to the power positive 2. It's negative 1 times negative 1, which is 1, and then 1 over 1 turns into 1 anyway. So that wasn't that exciting of an example, but at least it kind of hints at what we do with negative exponents. But then now that we've simplified all these powers of powers, we still have some multiplication happening. X to the 15 times x to the minus 4. How do I combine the exponents when powers multiply? We just have to add them. So the number of x's that I have is 15 plus negative 4, 11. And the number of y's I have is 6 plus negative 2, 4. And then multiplying by 1 is invisible. And so there's my final answer. So to get the ball rolling on this intermediate level, we had to first distribute the power across the multiplication in each of my quantities here. And then once that's done, I get a whole string of factors, each of which falls into one of the exponent rule categories that we knew at the beginner level. After we implement all of those exponent rules, generally implementing the exponentiation to multiplication rule first and then the multiplication to addition rule second, following the order of operations, we end up doing all the exponent arithmetic, and as far as it goes is as far as we have each variable only represented once in one of the factors. So I only have one place where I have x's, one place where I have y's, and then I have my numerical coefficient. Probably the most common place to screw this up is actually here, right? In either forgetting to apply the power to the number coefficient, so forgetting to do 2 to the power 3 and just keeping 2 as it is, or if you do apply the power, accidentally applying it incorrectly. So some people will write 2 to the power 3 and then accidentally write 6 here, okay? Thinking of it as 2 times 3. Most common errors here are just confusing multiplication with exponents. Right? If you can keep those two straight, then you're in better shape. The intermediate level polynomial skill is going to be to multiply two polynomials. And here again, I'm going to add some color to this by saying multiply polynomials by using the distributive property, which is sometimes also known abusively as FOIL. Okay. So let me shrink this exponents example so we can get some space. The board is only so big. So let's suppose that I want to simplify x squared minus x minus 1 times 2x plus 2. How should I do that? What do I need to multiply by what in order to carry out this multiplication? This is where I like to borrow from the new math. I say the new math is a little bit derisively. I like to use these little multiplication grids. We've seen them before this semester. For me, I like them a lot because they help me make sure that I don't forget any of the products that are necessary to carry out this operation. So I'm multiplying in this example a trinomial, a polynomial with 3 terms, by a binomial, a polynomial of 2. And so I know up front that when I do all my multiplication, I need to have 3 times 2, 6 different products. Right? Because every term from the first factor has to multiply every term from the second factor. And so now that I've set up my grid, all I have to do is fill in each of these squares as the product of the thing on its row and the thing on its column. So the uppermost left x squared times 2x is going to give me what? 2x to the third. Again, adding the exponents because we're multiplying the powers. Right? X to the 1 times x to the 2 gives me x to the 3. And so then I'll go in and fill the rest. 2x times minus x is minus 2x squared. 2x times minus 1, minus 2x. X squared times 2, 2x squared. Minus x times 2 will give me a minus 2x. And then minus 1 times 2 will give me a minus 2. So now I have all 6 of my terms laid out. So then how do we combine all 6 of these terms together to get my final answer? For that, we go back to our beginner level skill. Combine these polynomials together, add them together by combining like terms. So where do I find some like terms in this grid? Well, all of my x squareds are like terms. So when I combine them together, 2 of them added to negative 2 of them, how many do I end up with here? 0. So in fact, my x squared terms end up canceling. How about my other pair of like terms? Yeah, and actually I think did I do this right? Yeah, I guess so. So negative 2x and negative 2x are going to combine together to give me negative 4x. And that accounts for all my pairs of like terms from within this diagram. And so then I still have my 2x cubed and my minus 2 that didn't have a like term to combine with, and so they just carry through into my answer. And so my answer here then is 2x cubed plus 0x squared, so I won't write that, minus 4x minus 2. And the key skill here is to realize up front how many products you end up having to do. Trinomial by binomial means I have 6, 2 times 3, powers to do. And so I use this grid to organize my calculations and make sure I don't forget anything. And once I've carried out all of those multiplications, then all that's left to do is to combine like terms, which was our beginning skill. Real quickly, our advanced skill. And I'll send you home with a practice quiz. And I'll post the answers to it on Blackboard. So for the advanced level skill, we just do everything that we were doing up here. So using multiple exponent rules to simplify, but then also have negative exponents in our answer. But we kind of talked about what to do with negative exponents already, so let me just refresh your memory. Let's suppose that we did this same simplify problem as before, but I'm just going to tweak it a little bit. 2x to the 5th, y to the 3rd. But instead of the third power, let's make that the negative third power, times minus x squared y, and maybe I won't put an exponent on that one. So let's suppose I'm doing this problem. I take the same steps as we took before. I'm going to skip through them because you can watch them on YouTube, again, if you like. I'm getting 2 to the minus 3, x to the minus 15, y to the minus 9. I'm going to get negative 1. I'm going to get x to the power 2 and y to the power 1. And then when we apply our addition of exponents, we're going to end up with negative 15 plus 2 is going to give me, for the x's, negative 13, factors of them. For the y's, negative 9 plus 1 is going to give me negative 8. And then this negative 1 I'm just going to kind of put out in the front of everything. But now my final answer has negative exponents in them, so we have to do something about that. How should I rewrite, let's take the y to the minus 8, how do I turn that exponent from negative 8 into positive 8? What do I have to do?
G pushes you 1 and then over.
Right.
You do that what you did before with the 1 in parentheses.
Mm-hmm.
Negative 8, I think.
Right, so I take that power, y to the minus 8, and I rewrite it as 1 over y to the 8th, positive 8th. And when I do that, the effect that that has is it takes the y to the 8 and it just drops it down into a denominator. So that y to the minus 8 upstairs is equivalent to y to the positive 8 downstairs. And that's how we move negative exponents inside of an expression. Right? If it's negative, we just push it into the other part of the fraction. So what happens with the x to the minus 13? When we move it downstairs, it becomes x to the positive 13. And then we can take it out of the numerator. What should I do with this 2 to the minus 3? Yeah, same thing, just like we did with the variables. Just drop it down into the denominator and make it 2 to the positive 3. Yeah, exactly. We're just flipping the fraction, basically. And then this negative 1 just stays upstairs. It's not a negative exponent, so we can keep it where it is. And we decided before that 2 to the third power was 8, so we'll just replace that with 8. Okay. So anytime you have negative exponents in your answer, just move those factors, move those variable factors from numerator to denominator or vice versa, and you can make them back into positive. So that's the advanced level skill here. It just kind of adds a little. Finally, and this really doesn't take time, our advanced level skill for polynomials is to square a polynomial. And so let's take, for example, this first polynomial, this factor from our problem here, x squared minus x minus 1. What if I ask you to square that? What would you do? I would say it's almost more important in this example to know what not to do. What not to do, please don't do this. So many students do, and it's incorrect. What not to do is to just distribute the power across the addition and subtraction. That is out of bounds, because as we'll see, it gives us a very different answer than if we rewind the tape for a minute and just think, what does it mean to square something? It really just means multiply it by itself, right? So the better path to take is the path in which we rewrite this square as a multiplication instead. So I'm just going to rewrite x squared minus x minus 1 quantity squared as x squared minus x minus 1 times x squared minus x minus 1. Because by rewriting it as multiplication, we take it from an advanced level skill back to an intermediate level skill that we know how to do. Right? So x squared minus x minus 1 times x squared minus x minus 1. And what we notice immediately is we're going to have 9 different products to do to carry this out, which is a whole lot different than the 3 operations we would have had to do if we just distributed the power. So clearly, something is different from this approach. When I do all of those operations, I'm going to whiz through them here, minus x cubed, minus x squared, minus x cubed, plus x squared, plus x, minus x squared, plus x, plus 1, and then combine all of my like terms. These minus x cubes are going to combine together to give me minus 2x cubed. I'm going to write that down here, I guess. Minus 2x cubed. I have an x to the 4th from the top left that doesn't have something to combine with. My x squareds are arranged in a way that if I combine them all together, I have a plus and a minus, but then I also have an extra minus. So they're going to combine together to give me minus x squared. The x's are both plus x, so when those combine, I'm going to get plus 2x. And then I have a plus 1 at the end that doesn't combine with anything. So anytime you square a polynomial, you should always rewrite it as a multiplication problem. Because that's what squaring is. It's multiplying something by itself. So if you try to take a shortcut, you're not only doing something that doesn't always work, you're doing something that almost never works. You're almost never going to account for every term that you need in this product by just distributing a power across addition and subtraction. So turn every squaring problem into a multiplication problem. The instructions on a lot of the problems in inside of Alex are a little strange. They'll say something like, rewrite without parentheses and simplify. That, to me, doesn't make any sense. What they really mean is to do this. Turn it from squaring into multiplication by itself. And once it becomes multiplication by itself, we have a strategy to deal with multiplying polynomials.